Hello learners, welcome back in the series of C programming language. In this topic I'm going to discuss about an important data structure that is called array. In this lecture we're going to see very limited points regarding the array. It is a very vast topic and this introductory lecture is also going to be, I think it will take more than 30 odd minutes, okay, 30 to 40 minutes. Okay, so please stick to the lecture till and watch till at the end. Okay, so following topics we're going to cover in this lecture: array declaration. Okay, we're going to see declaration. Then second point we're going to see initialization. Okay, third point we'll see the input, how to take input and output, produce the output, and fourth point we'll see the memory management or memory addressing, we can say, how memory is allocated to the array. In this lecture we're going to see about the static array allocation. Okay, so we're going to the following topics we're going to cover up. So let us kick start with the explanation on the definition. What is array? Let us first understand. Okay, so look at the definition here. An array is a data structure, so it is called data structure. So that means it is another data type, right? It is another data type. So we have already seen few data types: integer, float, okay, character, and all those things we have already seen. Okay, so this is not a naive data type that is come up with the language. You have to build the data type based on your requirement. Okay, so this data structure or this data type we also called a derived data type. So you can also note down. Okay, we also called derived data type, right? Fine. So it's supported by all the languages, either in the name of array, either in the name of list, that allows to store a fixed size collection of elements. Now this is important. Elements. So if you remember in our previous explanations, these data types, integer, float, and character, they can store only one element, right? Only one value. But it says that it is a collection of elements. Okay, collection of elements. That is the difference between the naive data type and this array of same data type. Now let us come and see this and try to understand this point. Same data type. As I already mentioned just beginning of this discussion of the definition, it is a data type, but I told it is a derived data type, right? It is not a naive or a primitive data type that is come with the compiler. Okay, so what it can do, we need to design it and by using other data types that we have already learned. So that means we need to use int, we need to use float, we need to use char to create these arrays. Okay, and they come up with fixed size collection of elements, means these arrays are capable to store more values of same data type. I hope the definition is clear. More values of same data type, right? Okay, and the elements are storing in contiguous memory location. So that is another key point that I have highlighted in the bold phase, right? Continuous, that can store into continuous memory location. I hope you remember during the discussion of data type when we have mentioned that whenever we have created an identifier as a variable or constant, and when we assign some value, it actually stores into a memory block, and this memory block has a name now a and its value 3, and it also has an address which is taken care by the operating system of your computer. Okay, the assigning the address is not in our control. Programmer cannot control which memory block will be reserved for the program execution. That is totally under the control of operating system. So same thing they are talking about here also. So contiguous memory location, and each element can be accessed using an index because they can store multiple elements. So there should be some mechanism. How can I access multiple elements? Because see, if I want to access this, I simply write a. So the a will replace by its value. But when you already have multiple values, how can I access them? How to represent which element I want to access? So that can be accessed through index. Okay, so I hope the definition is clear. If you not understood the definition, please rewind the video, okay, and go back and try to cover up whatever we have discussed regarding the definition. Okay, now let's move to the further part. Now we're going to see how to declare an array, and let us understand this definition more properly. Okay, so we directly will jump to the GDB compiler and let us discuss how to create an array. Okay, fine. So let's see. So the syntax, let me just write the syntax for you here. Syntax will be, we come up with a data type, right? Okay. Then name required, the name that we have already seen how to decide identify name, the rules also applicable here. I think most probably in third lecture I have discussed. And then it has a pair of a square bracket, and inside the square bracket we will mention a size and then end with a semicolon. This is the syntax for declaring an array. Declaration. Okay, so now let's expand this syntax and let's try to understand it more in detail. So when you say data type, the data type that we have already understood now, that integer, that float, okay, then we'll see character array is a string, we'll see them later, then short and long double whatever we have. So any of this data type you can pick, right? And this name, we know how to give a name, and this size is a positive integer greater than 0. Okay, it should be a positive integer. Remember, size for the array cannot be a floating point value. It's a positive integer always. A size cannot be negative. Similarly, size cannot be 0. So it should be greater than 0, positive integer, right? So let's declare the array and see. Suppose I want to store 10 numbers. Okay, so what I can do, so let us first decide I'm going with store 10 integers. So given a name, and now I save given the size. Okay, now see, I've exactly tried to replicate that particular syntax that I have written here. This is the syntax, right? Okay, so data type here in my case is int. This is the data type. Name is nums. Okay, name is nums, and the size is a positive integer, and size in my case is 10. Okay, so this is just a declaration of an array. I have not done any initialization. Okay, so how it will look like into the memory? As in the definition, they have mentioned that it is a continuous memory location. So how it will look like? Okay, so let's draw a picture for you to understand this. So it will be a continuous memory block, 10 memory block. Okay, so if 10 memory block, each memory block have a size. So what will be the size? So size will be decided by this type. So size will be 4 byte. 2, 3, 4, 5, 6, 7, 8, 9 and 10. What is the name of the array? Nums. Okay, and also see in the last line memory locations. Okay, so locations have what? Locations have some index. Okay, so and address. So each element can be accessed using an index. So what will be the index? Remember, in C programming, index start from 0. Okay, so please use pen and paper to understand this. Okay, index start from 0. I hope you understand. I am not going to write other square brackets. You can assume others are also in square bracket. So this is the start index. So these are the index. This is the start index, and this is the end index. So look at carefully the end index. Your size of the array is 10. The end index is size minus 1. Okay, so just you can write here, start index is always 0 and end index will be size minus 1, right? So size is 10. You can see the end index is 9. So then sir, what will be the value? As of now, this is just a declaration. I have not initialized, so all this will be garbage value. Okay, how to access them? So let me show you how to access them. Okay, so let me show you here how can we access them. So to access them, suppose I want to access the first item. So how to do that? So use the name of the array and which index you want to access. You need to take the decision. Okay, suppose sir I want to access this location. So this is the third location, first location, right? First location, second location, third location. So always the index will be -1. So index 2. So how you can want to access it? So I'm going to pass it 2. Look at how I am accessing. I want to assign some value. So let's assign some value here. Clear? And okay, can I print it? Okay, so I want, would you like to print the only one item? So let us print only one item, and printf. Okay, integer %d. Which item you want to print? The item I just initialized, that is nums of 2. Okay, let's just do nums of 2. Done. And let's try to execute the code and see everything is fine or not. Okay, see, I initialize with the 7 and I get the value 7 back. Okay, now sir, you have just initialized only one block. Can I initialize the array at the time of declaration? Fine. So let me just erase it here and let me just initialize it. This is what, this is the declaration. So please only array declaration, okay, with initialized with garbage values. Okay, can you just show us just all the garbage values? Okay, now see, most important part here. Let me go back. We'll see other things later. Let me just add some space here. And let us discuss. So what I have done, I have just created one array, right, with the 10 memory blocks. Fine. Okay, so 1 2 3 4 5 6 7 8 9, index 0 1 2 3 4 5 6 7 8 9. Okay, so right now I have just only initialized that index with 2, so only 7 is there. What about others? Others are garbage values. Okay sir, how can I access all the items? So let us print all the items. How to print? So now look at the difference between two continuous index. What is the difference between them? +1. Okay, what is the difference between them? +1. What is the difference between them? +1. Similarly, what is the difference between them? +1. Okay, so I can, if I somehow reach to this location, what I will do, I will do +1, I can go here, I will do +1, I am here, I will do +1, I am here, I will do +1, I am here. Okay, this way I will again do +1, I will be here. So now question is that how to reach the first index or the first location, how to reach here. Now another important point regarding the array, you must remember, okay, you must remember the array name, please note down, the array name has the base address of the array. The array name has the base address of the array, most important part. Means if the name of the array in my case is nums, using the name I can reach here, right? So you can also use the index to reach here directly using an index. So what will be the index of this location? The index of this location is 0. So how to reach there? Simply you're going to write nums of 0. You can easily reach. Okay, so nums of 0. So then sir, how can I go to the second index? So now to access an array, we'll take a loop. Okay, so I preferred always for loop. So we'll take a for loop. Because if you look at this, I can easily decorate my code using a loop like this. For I'll start with the start index, okay, I'll go up to the last index, not including, I'll go up to the size of the array, okay, and then I'll keep incrementing the value of I by 1 so that I can easily move 0 plus 1 to 1, 1 plus 1 to 2, 2 plus 1 is 3, 3 plus 1 is 4, like that I can continue. Okay, so I hope you understand how I can access it. I'm going to access it using a loop. So we'll prefer for loop. You can see any book, any website, you will see we always prefer the for loop. This is the most decorative loop that is introduced in the C programming. Okay, and let us now see how I can access it. So I'm taking a for loop. I'm going to declare the initialization. I'll access up to the size, that is the condition. I'll get the next index by incrementing by 1. Okay, so now let us print the array. So I'm going to print the array as well. So I'll print the index and then I'll print the value. Okay, so let us print the index. So index will be I and nums of I will give me the value. Okay, so let's run this. See here, sir, all the locations are 0. It is not guaranteed. Here in this compiler we get the 0. You can check on your computer, it will be maybe garbage value. So for the time being, if you did not initialize the array, it will be garbage, means only garbage. Now see, how did I access them? Simple. I get the start index. Okay, where is the start index? Yes, you see here I get the start index as 0, right, and it keep updating the index. So I started with 0, it is checking here, 0 is less than 10, yes, so it prints me the value of 0th index. Then before it is going up, the updation get executed by plus plus, so it's become 1, so I get the second index. So I get the again 0. Similarly, I get the third index, which is updated here at line number 8. So it prints me 7. Right. So I hope you understand how to access an array. You can access an individual item the way I did, or you can access all the item one by one throwing a loop, using a loop. Okay. So please prefer for loop because it is easy to work with an array and it is designed for mainly one of this reason. Okay. So now next, let's move back. Sir, can you initialize the array like other variable? Is it possible? Can you initialize? Yes, it is possible. So let us initialize the array. Okay, I'm not going to change the nums, or I just going to put this in comment so that you are not get confused. So I'm declare it again and now see how I can initialize. So 10 values, right? I think I have done. Okay, 1 2 3 4 5 6 7 8 9 10. Yeah, so 10 values I have initialized here. So this is what this is, initialize, declaration and initialization together. Okay, declaration and initialization together, right? So now see the most important part, to initialize. Okay, to initialize an array, what we can do, the most basic part is that while you declare the array as following the syntax, the same syntax, right, use an assignment operator like other variable. We also did this way now. Yes, so same thing, using assignment operator only we can initialize. And but here you are going to initialize more than, you're going to provide more than one values. Okay, you're going to provide more than one values. Previously you are providing only one value, so there is no issue, just put the value and end with a semicolon. Now here more than one value. How many value? The number of values should equal to the size of the array. So here size of the array is 10. So compiler expecting that you must deliver 10 values here. But how to deliver? That should be comma separated. Careful. There is no space separated concept like scanf. Okay. All the values must be comma separated. Clear? And see, while you initializing, it should start with the open curly brackets and it must end with the close curly brackets. So this is called declaration and initialization, and once you're done the initialization, it must be end with a semicolon, like because it is a statement. In C programming, all statement must be end with in semicolon. Okay, so I hope you understand how we can initialize it. Fine. So let's execute the code and see are we getting the output or not. Okay, now see here, some 5 get printed. Okay, I just want to access it, leave it, or you can see no issue. So let us see, I'm using the for loop, and through for loop I'm getting all the values, right? Okay, I did not update num2 in between, so I get the num2 as 5 0 1 2. Yes, num2 is 5. You can see num2 is 5, right? And later you can see here I want to access only a single item, so I want referring num2. So what is num2? So num2 is now 5. Okay, so now if I go back here and let me just discuss with you here. Suppose I want to initialize it with the some value, so I'm initializing 3 4 5, right? 6 7 8 9 10, and then we have 11, and then we have 12. These are the values, right? So for loop requires, we have already understood this, so we need a for loop. Clear? There is no doubt. So this is the start index, and your every index will be verified against the given condition. And how to get the next index? By updating the index by 1 using the increment operator you can do here. Okay, I hope that this part is clear. Okay, this part is clear. And now another part. Now let us see any shortcut approach to initialize an array, right? Is there any possibility? So let me just show you here. Suppose I want to declare another number, another array, nums2 and 10. Okay, and this is one of the way that you can do. Yes, remember here most important part, what will happen if you do this kind of initialization. Previously you have provided how many values? 10 values. This 10 values is equal to the size of the array. Okay, now here I did not provide the 10 values, I provide only 1 values. Okay, so remember you can note down, you can, or I better to write it here so that later I will provide this with the description of the video, and you can also refer this. So initialization, right? Okay, so you can initialize the array by passing comma separated values, as we have already seen. Okay, comma separated values, right? But when you do this, what it can do, all the memory location will be updated by 0. Okay, will be updated by 0. I hope that this point is clear, right? So let me just show you here. Did I print? No, I did not print num2. So let us print num2, nums2, nums2, and now run. So let us see the output. Yes, here you can see the output. All the values initialized to 0. You might thought I maybe also I can initialize any other value. So let us try. No. Run it. See. Now in this case, what is happening here? Look at the first output. The first output is only 4. Others are 0. Okay. So let's try to understand this here. Whenever you try to initialize the array with a single value other than 0. So here I have used 4, I did not use 0. So instead of 0 I have used 4. So this value will be assigned to the first index of the array, only first index. So what about the other index? For 0 will be now assigned for all other index starting from 1 till the size minus 1. Okay, so remember, if you want to initialize the array, you can use curly brackets 0, then all the values will be 0. So technically means I want to say that if you do this, you can only get the first location. Okay, you cannot access all the location by assigning only one values. So once you have assigned value for one location like this in line number 10, okay, rest of the location will automatically initialized with the zeros, rest of the locations. Okay, so this is two different ways. Another way is also there. This is the first one that we have seen here, by passing number of values equal to the size of the array, and second one we have seen, if I do pass only one value, it will only assign the first locations, right? Okay, so let us try to pass more values. Let's see what is happening. Okay, now I pass 3 values. Now run. Now see, only 3 values are initialized. So what about the others? Others are get the 0. Okay, so how to remember how many values I need to initialize? Is it very difficult now? Every time when I declare the array and then I try to initialize the array at the same time, I need to count that I have actually delivered the required number of values or not, or at least less than the required number, right? So don't worry, there is third way. No need to count while you initialize them. Let me show you. Nums3. Okay, you don't know how many values going to pass. Okay, leave it. Fine. How many values want to pass? Pass it as per your requirement. Okay, see, array can have duplicate values, no doubt on this. Here I did not know actually how many values are there. I have passed, simply pass. I need to store this value, so I have stored it in a continuous memory block. So now next question is that, sir, if you do this, how can you get to know the highest index? Okay, so here is the technique. So let us calculate the size. Calculate the complete memory allocated to you. So I hope you remember, we know an operator is there that is called size of. Pass the array, okay, nums3, and what is the size of individual location divided by that. Because data type is integer, so size of each block is 4 byte. So this will give me the complete memory allocation for num3, and this will give me the size of individual block that such as nums30, nums34, nums32 individual locations. Why? Because while I declaring the array, I inform the compiler that I need each memory block of size int. I hope it is clear. Got it? And this one will give you the complete size that you have reserved. Okay, this is called static memory allocation. Okay, so this way allocating memory, okay, we called it static memory allocation. So all static memory allocation done at compile time. So that means in advance you are reserving the memory blocks. Okay, so now see, if I don't know how many values I want to pass, I simply want to initialize. I'll refer this. No need to count how many values you have passed during the initialization. I can later recover the size of the array using this particular formula or the particular statement or particular expression, whatever you want to say. Okay, it is possible that I can pass the size during the declaration and also initialize the array. And similar way, I can also pass the partial values. I can initialize the array partially as well, right? Okay, so let us just execute num3 so that you get to know this formula is working. Okay, remember this size of gives me the complete memory reserves for array. Okay, and this will give me size of individual block. Okay, fine. So now let us execute this num3 and see. I told you this video will be little bit larger. It will take around 40 minutes or maybe 1 hour also. So stick to that video. Okay, stick to the video and let us complete this topic. Okay, so now I want to access num3. I don't know the actual size, so I'll use the size variable that I have taken at line number 15, and now I want to print num3, right? Num3, and I also going to change it here. Now let us see we get the all correct values without any issue over there. Okay, without any issue over there, correct and efficient. Okay, so it is very clear now to us how to declare an array, how to initialize an array, three different techniques that I have shown you, and also if I forget to specify the size, is there possibility that can I get the size later? Answer is yes. Okay, now move further. Okay, here is there any possibility? Suppose I do not want to initialize the any number in between, so I leave them as comma and I pass the next item. So compile time error. No, we cannot initialize the array this way. Not allowed. Fine. So new thing, right? Remember. Now next point we need to see. Suppose okay, here another one. Suppose I have declared an array here, nums4 with size 10. Okay, and can I initialize it later? Can I do this? Now can I pass this all 10 values now? Now see, try to understand, use the common sense here. You allocated the memory, done. So memory already initialized. This line number 19 is not initialization. You are trying to updation. Okay. This line number 17 itself is initialization with the garbage values. Correct. Garbage values. No problem. But here, look at here. What you trying to do? Did you try to correlate? See, this line number 19 and line number 22. Is there any difference? No. Here in line number 19, you did write the wrong syntax. You want to access the 10th location, but 10th location is not there. Highest index is 9. Highest index is 9 because size is 10. So it is wrong way of accessing this. So this will leads an error. It will be compile time error because you cannot assign multiple values in one location. See the error. Expected expression before something else, but we get the error in the line. So once you done the declaration, later if you want to initialize, you need to initialize only one location. You cannot change that one. Okay, you cannot change that one, and the index should be always greater than equal to 0 and size minus 1. So before you accessing any location, so please check your index. So let me just take an index. So if I take an index from the user, so let me declare a variable here, index, right? Okay, and ask the user to enter an index that user wants to access, and here user can enter any index. So it is your responsibility to check the index. Is the index greater than equal to 0 and is the index less than 10? If yes, then update it by, suppose you want to take a value as well. So let us take value. So at the same time, first one is the index space separated value 50. Sorry. Yeah, space separated value val done. And now if I just pass the val here, done. Okay, so see, most important part at runtime also you can check the index. If you ask the index from the user, whatever user can enter, we cannot control the user's input, but we can check the user input. So I am used here if statement, and I put the condition: is the index entered by the user is a greater than equal to 0 index? If it is greater than index, is it within the size? So I am checking index less than 10. Fine. And because my size is 10 here, this should be less than 10, it should not be less than equal to 10, and I'm updating that particular index by the given value, right? So now let us print and check. I'm going to just only print now nums4 and let me just put others in comment. Fine, now run this. Okay, what is the issue? Size, where okay, it is not size anymore, that is now 10. Run. Yeah, waiting for the input for the scanf. I did not use any printf, say enter what. So first one is the index, so I'm entering suppose index 89. Okay, and now I want to enter the value on that index. Now see, your array is not updated, it have 0 only. Got it? So if you enter the wrong index, you also need to inform the user printf enter a valid index. Run it. So now if the enter 89 and the value 3 and yeah, see, enter a valid index, wrong output. Got it? We get it, the correct one. And after this we must use one \n, right? Okay, now run it and see. Okay, index, now I give 2 and the value 8. So now see, index num2 I get nums4 2 is the index 8 and value get 8 and no else is there. So because I have entered a correct, I have entered a here correct index, and it works also fine. Okay, so I hope you understand the declaration initialization. This is the way you can declare an array, right? And this is the way you can initialize the array at the same time. Here one point we need to take care very carefully, the size of the array and the number of values you are passing, it should match. Okay, you can pass less than the size as we have done at line number 11, but do not pass more than the size of the values. We will discuss, we'll see what will happen. Right now we are not the right position to understand this topic. Okay, we'll see. In the array also we'll discuss. Now suppose initially we don't know what will be the size, but I just want to initialize it with random values. So you can set the any number of random values. While you initialize it, you must use a curly brackets and comma separated values you need to pass. Careful, the values you are passing in the curly brackets, its type and the type of the array should match. Do not rely on the typecasting. Do not pass float or character over here. Satisfy the criteria. If you declare it integer, so please declare the values of same type. Now once we declare the array and initialize the array, but we did not specify the size, it is also possible for us to get the size of the array back. How? Using this formula. You can use size of operator and pass the name of the array. So what it will give you? It will give you the complete memory block reserved for this array. Okay, so assume that there are 5 items. So 5 into integer 4 is the each size of the integer. So 5 into 4, 20 bytes, and size of each memory block is integer. So what I am passing here int, because nums type of nums3 is also int, and we are also working with the nums3, right? So it give me the number of memory blocks reserved for this array. And it is also possible that we can ask the user to give an input for an index and value where I want to update based on our requirement. So user can enter any value as index. It is our responsibility to check the index is valid or not. So that can be done using if statement. So in the if, we have used this particular condition, index should be greater than equal to 0 and it should be less than the size. So for the nums4, we know the size is 10. If suppose you want to use nums3, so instead of 10, here you can use size variable, right? So if the index given by the user, it is come within this range, so we can update the particular index by the value given as input by the user. If the index is wrong, this else statement will take care of the stuff. And this is the way we can print the complete array. We can access all the items simultaneously one by one by using a for loop. The initialization should be start with the index 0, and the condition should be the size of the array, and each index is incremented by 1. So I have used here post increment operator. You can use pre, okay, or you can also write I equal to I plus 1. All will be given the same outcome, okay. Fine. Okay, one more thing. Now let us take the input of the complete array and just print, and we're going to stop it here, okay, because it's already around 40 minutes, right? So one quick stuff we're going to see now. Suppose we're going to now take the input for all the numbers. So for taking input, definitely we need all the index. So I'm declaring here with the for loop. I'll generate the index, right? So you can give a message printf enter value for, we are using nums4, okay, so you can print the index here, okay, and we are getting I, and then we are passing the scanf statement %d. You need the address of individual memory block. So how to pass address of nums I, okay. So this is the way you can pass. It will repeat in loop, okay. It will get the address of individual memory block, okay, and it will assign the value into that respective memory block. In the next lecture, we're going to see about this addressing concept, right? Okay, so let's execute and see. Some error is there. Okay, it's not nums, sorry, it's nums4. Just name. Yeah. Now see, it is waiting for the input. So I give 7, I give 8. Sorry, careful, no floating point numbers. 89, okay, 77, whatever value you want to enter. 45, okay, 89, okay, 11, 2, and 0. Now see, I get all the values correctly, whatever I have entered, right? So now I think input, output, initialization, declaration is done. And we have also discussed about the array definition, okay. Remember, it is a data structure which can store multiple elements of same type, and we can access the array item using an index. Index will be a positive integer started with 0, last index will be the size -1. To access an array locations, we preferred always for loop because it is follow the standardization here. We start with the index 0 and continue till the last index by incrementing by 1. Fine. And different way we have done the initialization, correct. We have not discussed the purpose and advantages. We'll see in the array step by step, okay. Thank you very much. Have a nice day. If you like my content, please share this content with your friend, and do not forget to subscribe our channel. Thank you very much.